Welcome viewers. In this video, we will be expanding the binomial expression 2x plus y all raised to the power of 3 using the Pascal's triangle. In this video, we will be using the Pascal's triangle to obtain the coefficients of the binomial expansion. And our binomial expansion is 2x plus y, everything raised to the power of 3. Now we have a term, the first component, 2x. 2x is a monomial, and y is a second component, which is also a monomial, a single term, a single expression, a single algebraic expression. When you combine the two algebraic expressions, 2x plus y, you have a binomial. And 2x plus y is a binomial. And since we are now raising it to the power of 3, because 3 is the exponent or power, then we will have a binomial expansion. Now, what is this expansion? The binomial expansion is simply 2x plus y, all enclosed in the bracket raised to the power of 3. And this simply means 2x plus y multiplied by 2x plus y, and then multiplied also again by 2x plus y. That is to say, 2x plus y is multiplied in 3 places because 2x plus y is raised to the power of 3. But in this particular video, we will not be expanding it manually. What we will be doing is to use the Pascal's triangle. Now, we have 2x plus y raised to the power of 3. Remember we said the exponent is 3, or we can call it the power. So n is equals to 3. So we'll be using the Pascal's triangle. If you have not watched the previous video that I explained very well on the Pascal's triangle, kindly see the link above for further details. Now, what we have here is the Pascal's triangle. We have the Pascal's triangle from row 0 to row 8. You can go beyond row 8 just for the purpose of this video. Our interest is n is equals to 3 because our power is 3. The exponent we have there is 3. So we are more concerned about row 3. And what do we have in the row 3? We have the coefficients. We have the coefficients of the expansion when n is 3. Now, just a quick rundown on this Pascal's triangle. You'll notice we start with 1, and then we move to 1, 1. Notice that all the rows start with 1 and end with 1. Now, how do we get this middle term? 2. What we do is to add 1 plus 1 to get the middle term below. Remember, like I said, it starts with 1 and ends with 1. So if we move to row 3, which is our row of interest, we start with 1 and then end with 1. Now, how do we get the middle terms? Look at the preceding terms on top. We have 1 above. 1 plus 2 gives us this 3 here. And then this same 2 plus 1 gives us this 3 here. So we just stop here because the coefficients we're interested are where n is 3, n being the power 3, and we are using row 3. So we have 1, 3, 3, 1 as the coefficients. So we look at a plus b raised to power n, and in this particular case, our a is 2x, our b is y, and our exponent n is 3. Now when n is equals to 3, that is when the power is 3, all we do is to go to row 3 of the Pascal's triangle, and we get the coefficients. Here we have 1, 3, 3, and 1. So in a scenario where we have a plus b raised to power 3, what we simply have is as shown, where we have our coefficient 1, 3, 3, and 1 as clearly shown. And our first component here, which is a, is raised to power of 3, and that's what we have right here. And then as we go to the right, a raised to power 3 will now become a raised to power 2, then reduces to a raised to power 1, and then finally reduces to a raised to power 0. While this second component, b in this case, is b raised to power 0, and then increases to b raised to power 1, and then b raised to power 2 until it becomes b raised to power 3. Notice clearly that the sum of the components of both a and b, that is the exponents, the powers, 3 plus 0 in this case is equals to 3. So the sum of the powers, or the sum of the exponents, gives you the value of n. And in this case, our power is 3. So if you look at the right, you have 2 plus 1, which is 3. Here the power 1 plus the power of 2 is 3. 0 and 3, if you add them, it gives us 3. So if we simplify this further, we have a plus b, everything raised to power 3 is a cubed, plus 3a squared b plus 3ab squared plus b cubed. Now we know that our a is 2x and our b is y. So what we simply do is to substitute. Wherever we see a, we put 2x, and wherever we see b, we simply put y. So when we simplify this further, we have as displayed, and then we keep simplifying it further, and then finally we have 8x raised to power 3 plus 3 into 4x squared into y plus 3 into 2x into y squared plus y raised to power 3. And then if we simplify further, we have 8x cubed plus 12x squared y plus 6xy squared plus y raised to power 3. And that's our answer for the expansion 2x plus y all raised to power 3. Thank you. Kindly subscribe, like, and share.